Next, we will move on to the next topic, PGP operation email compatibility. What actually email compatibility? When PGP is used, at least part of the block to be transmitted is encrypted. If only the signature service is used, then the message digest is encrypted. For example, with the sender's private key. If the confidentiality service is used, the message plus signature are encrypted. It may be with one-time asymmetric key. Thus, part of all of this resulting block consists of a stream of arbitrary 8-bit oct. However, many electronic mail systems only permit the use of blocks consisting or containing of ASCII text. To accommodate this restriction, PGP provides the service of converting the raw 8-bit binary stream to a stream of printable ASCII characters. The scheme used for this purpose is Radix 64 version conversion. Each group of 3 octet of binary data is mapped into 4 ASCII characters. This format also appends a CRC to detect the transmission error. The use of Radix 64 expands and message by 33%. Fortunately, the session key and signature portions of this messages are relatively compact, and the plain text messages have been compressed. In fact, the compression should be more than enough to compensate for the Radix 64 expansion. For example, if you're going to see an average compression rate ratio may be 2.0 using a zip. If we ignore the relatively small signature and key components, the typical overall effect of compression and expansion of a file length x would be 1.33 into 0.5 into x, that may be 0.665x. Thus, there is still an overall compression of about 1/3. So, one noteworthy aspect of this Radix 64 algorithm is it blindly converts the input stream of Radix 64 format regardless of content. Even if the input happens to be ASCII text, thus if a message is signed but not encrypted and the conversion is applied to the entire block, the output will be unreadable to the casual observer, which provides a certain level of confidentiality. As an option, PGP can be configured to convert to Radix 64 format only the signature portion of the signed plain text message. This enables the human recipient to read the message without using PGP. So PGP would be still have to be used to verify the signature. For example, we will see about the particular operation. This figure, the relationship among the 4 services so far what we discussed is going to be present over there. On the transmission, generic transmission diagram, which is going to be illustrated, or it's going to be illustrated over here. Let's see how it's going to be do the operation. On transmission, a signature is going to be generated using an hash code of the uncompressed plain text. Then the plain text plus signature, if present, is compressed. For example, a file which is going to be given over there, and whenever your signature is going to be required, then it can generate the signature, and that is going to be concatenated with the file, and that is going to be get compressed. If no signature is required, just simply the file is going to be get compressed over there. Next, if the confidentiality is required, the block is encrypted and prepend with the public key, encrypted symmetric encryption key. Finally, the entire block is converted to Radix 64. Example, for the compression, after the compression the data, if confidentiality is going to be required, then we can do the encryption process to provide the confidentiality for this particular operation with the public key, and the shared key. Otherwise, if no confidentiality is going to be required, straight away it's going to be given for the convert to Radix 64. This is going to be the operation which is going to be there in the generic transmission diagram. We will see about on the reception end. In the reception end, once the incoming block is first converted into back from Radix 64 format to binary, then if message is going to be encrypted, then the recipient need to decrypt the information. If it is not encrypted, then straight away the information may be get taken for the decompression. If the message is encrypted, then we have to go for the decryption process. The decryption process is going to be done with the private key of the user with the particular public key. Then we have to get the data over here. If the message is the resultant block is then decompressed. If the message is signed, the recipient recovers the transmitted hash code and compares it to its own calculation of the hash code. Otherwise, straight away the decompressed data will be taken over here. This is a generic reception diagram which is going to be present in the particular email compatibility. Let's discuss about the fifth parameter as service of the particular PGP operation, segmentation. And another constraint of this email is that there is usually a maximum message length, and PGP automatically blocks an encrypted message into segments of an appropriate length. On the recipient, the segments must be reassembled before the decryption process. So such a way, this PGP is going to be get operatable under the 5 services as we have come across with this particular thing: authentication, confidentiality, authentication and confidentiality both together, and email compatibility, compression, email compatibility, and finally the segmentation process. These are the 5 services which have been provided for the PGP operation. Let me see the summary of PGP services. Under the function, a digital signature is maybe used over there, or message encryption, compression and email compatibility. The algorithm which is going to be used over there, the digital signature is going to be TSS or SHA, or RSA and SHA, and which is going to be providing an hash code of messages created using this SHA algorithm. The encryption process may be an DSS or a RSA, which is with the help of a sender's private key, and which includes the message over there. The message encryption, the algorithm which is going to be used over there is nothing but CAST 128-bit or IDEA or triple key encryption. Triple key decryption is going to be used over there with the Diffie-Hellman or RSA. So here the description is nothing but the message is encrypted using the particular CAST 128 or the IDEA or triple DES with one-time session key generated by the sender. The sender key is encrypted using a Diffie-Hellman or an RSA with the recipient's public key, and which includes the message. The compression method which is going to be used over is nothing but zip compression method. So a message may be compressed for storage or transmission using the zip. Then email compatibility is nothing but we are going to use an radix 64 conversion method, which is going to provide the transparency for email applications as encrypted messages may be converted to an ASCII strings using an radix 64 conversion. Such a way, we have come to an conclusion summary of this particular video. In this particular video, we have come across with an introduction about electronic mail security. We have seen about the pretty good privacy protocol, the notations which have been used in the pretty good privacy, and operational descriptions, nothing but the services provided by the PGP, the 5 different services: authentication, confidentiality, compression, email compatibility, and finally segmentation. And we have come across with transmission and reception of a message in the PGP in the email compatibility, and finally we conclude with the summary of PGP services. Hope that this video would be helpful for you people to understand about the PGP operation, the pretty good privacy operation which have been used in the email security. If you have any queries, kindly you can post the queries to me. Thank you for watching this video. Thank you.